Hey there, and welcome to another episode of the wonderful world of geometry. In today's lesson, we will be talking about the Pythagorean Theorem. But what is the Pythagorean Theorem? I'm so glad you asked! The Pythagorean Theorem is a geometrical formula used to find any one side of a right triangle given two of the other three. But before we get into that, let's talk about the man behind the theorem. Pythagoras, or Pythagoras of Samos, was an Ionian Greek philosopher, mathematician, and founder of the religious movement called Pythagoreanism. Most of the information about Pythagoras was written down centuries after he lived, so very little reliable information is known about him. He was born on the island of Samos, and might have traveled widely in his youth, visiting Egypt and other places seeking knowledge. Around 530 BC, he moved to Croton in Magna Graecia, and there set up a religious sect. His followers pursued the religious rites and practices developed by Pythagoras and studied his philosophical theories. The society took an active role in the politics of Croton, but this eventually led to their downfall. Pythagorean meeting places were burned, and Pythagoras was forced to flee the city. He is said to have died in Metaponton. Pythagoras made influential contributions to philosophy and religion in the late 6th century BC. He is often revered as a great mathematician, mystic, and scientist, and is best known for the Pythagorean Theorem, which bears his name. However, because legend and other things cloud his work, even more than that of the other pre-Socratic philosophers, one can only give a tentative account of his teachings, and some have even questioned whether he contributed much to mathematics or natural philosophy. Many of his accomplishments credited to Pythagoras may actually have been accomplishments of his colleagues and successors. Whether or not his disciples believed that everything was related to mathematics and that numbers were the ultimate reality is unknown. It was said that he was the first man to call himself a philosopher or a lover of wisdom, and Pythagorean ideas exercised a marked influence on Plato and through him all of Western philosophy. So now that we know a little bit about the man behind the theorem, let's talk about the theorem. As stated before, the Pythagorean theorem is used to find any one side length of a right triangle, given to the other three. It states that the square of the hypotenuse, or the side opposite the right angle, is equal to the sum of the squares of the other two sides. The formula is written like this: a squared plus b squared equals c squared, where c represents the length of the hypotenuse and a and b represent the length of the triangle's legs. So how do we know that it works? Let's take a look at this video. So here we have a right triangle with its legs squared. The squares that you see there are filled with water. So let's see what happens. The squared legs are equally filling the squared hypotenuse, showing that truly a squared plus b squared equals c squared. We can also see here that c squared equals a squared plus b squared. To sum that up, a squared plus b squared equals c squared. Got it? Cool! Now let's see how we can actually use this formula.
To find the value of x in this example, notice that we have a right triangle, so we can use the Pythagorean theorem. The Pythagorean theorem states that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse, or a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. So here, since our legs have lengths of 6 and 8, and our hypotenuse has a length of x, we can set up the equation 6 squared plus 8 squared equals x squared. Solving from here, 6 squared is 6 times 6, or 36, and 8 squared is 8 times 8, or 64. So we have 36 plus 64 equals x squared. 36 plus 64 is 100, so we have 100 equals x squared. Now to get x by itself, since x is being squared, we must take the square root of x, and if we take the square root of the right side of the equation, we must also take the square root of the left side of the equation. On the left, the square root of 100 is 10, and on the right, the square root of x squared is x. So our answer is 10 equals x.
It was a quiet Sunday morning in the City of Angels, when all of a sudden a giant robot appeared out of nowhere. A distress call was put out to Professor Pogo and his students. Giant robot attacking! Help! The call was from the city mayor's office, and Professor Pogo and his students raced to the scene. Aha! This mechanical monstrosity bears the initials of that incorrigible delinquent, Tommy Rot.
That's right, Pogo! Try and stop me now!
Gee, what are we gonna do?
We'll blast him to kingdom come.
No. We will tie this rope from this parking meter to this fire hydrant and trip the robot sending it crashing to the ground.
Hasta la vista, Senor Roboto.
How short do you want the rope? Aha! You have asked the right question. We will use the Pythagorean Theorem to figure it out.
Pythagorean Theorem?
Yes. The Pythagorean Theorem states that if we have a right triangle, which means a triangle with a 90-degree angle, and we know the length of two sides, we can then figure out the length of the third side. In our case, the sidewalk and the meter form a right angle. The height of the meter is 3 feet. The distance from the meter to the fire hydrant is 4 feet. So now, with this information, we can then figure out how long the rope needs to be. The Pythagorean Theorem states that a squared plus b squared equals c squared. If our meter is 3 feet tall, we square the 3, which is 3 times 3, and that equals 9. Let's work on the 4. If we square the 4, that is 4 times 4, which is 16. 9 plus 16 equals 25. Now we need to find the square root of 25. What number times itself equals 25? Oh, that would be 5. Yes. This means that the hypotenuse, or the side that is opposite the right angle, is equal to 5 feet. The rope was tied from the fire hydrant to the parking meter. And when the robot took a step, it tripped and fell to the ground with a thunderous crash.
Dang, nabbit, foiled again. I'll get you next time, Pogo.
We have stopped Tommy Rot and his robot with the Pythagorean Theorem. Once again, Professor Pogo and his students have stopped the bad guy and saved the day.
I hope you enjoyed that last clip. But we're now nearing the end of our lesson. To close, I want to give you an idea of how technologies like GeoGebra can really bring the Pythagorean Theorem to life. I will walk you through how to first create a right triangle and then the proof behind the theorem. To start off, we need to make a right triangle. So I'll click on my segment tool and create a segment. Doesn't matter how long, or doesn't even matter if it's straight. Alright, after that I need to make a semicircle through these 2 points. So Thales' theorem states that if ABC is a triangle in a circle where AB is the diameter of the circle, then this angle will be a right angle. So let's check and make sure. Okay, and yes, it is in fact a right angle. And we can move that anywhere around our circle, our semicircle, and we'll see that it remains a right angle. So that's what we need. Okay, now we have our right triangle. So let's create our squares. So we want to see that this is squared. We want to square this and this and that. Okay, so we'll start off by clicking on the perpendicular line tool. We want to make a perpendicular line there, perpendicular line there. Once we've done that, we'll click on our circle tool and draw a circle using the length of this side. Once we've done that, we'll use our intersect tool draw the intersection point. Okay. From there, we'll draw a parallel line from this side to our point. And then another intersection point. Okay, another intersection point here. Now, as you can see, we have a perfect square. So we're going to click on our polygon tool and draw out our square. Okay, so I have a square here. I'm going to get rid of the rest of these lines that we don't need, just so that it looks clean. Okay, so we're going to do the same thing for our other two sides. So I'll just go ahead and do that. Perpendicular line, circle, intersect, parallel line, intersect, and then I'll again draw out my square. Get rid of, last but not least, hypotenuse, circle, parallel line, intersect, and create my square. Okay, so now we have three perfect squares along the edges, the lines of our legs and our hypotenuse. So let's figure out what the area is. So I'm just going to click inside these boxes to see what the area is of each one. And if you want to change the size, you can change it at this point and kind of do some shifting. Okay. Everything is kind of together at this point. Okay, so this is what we're going to do. Our formula says that a squared plus b squared should equal c squared. So let's find out if this formula is true. So I have my calculator. Now I'm just going to put in our a squared first. So a squared is 39.6. 39.6, and I'm going to add it to my b squared, which is 90.83, and I expect once I add it to get 130.43, and I get 130.43. Alright, let's try it again. So we'll shift it, change it, maybe get some different numbers. Alright, make it small, and let's get out our calculator. So here's our a squared, here's our b squared, here's our c squared. So a squared is 15.73. We're going to add it to our b squared, which is 36.09. And again, I expect to get 51.82. And I do. Alright. Thanks, guys. Thank you for tuning in to this week's episode of The Wonderful World of Geometry, featuring the Pythagorean Theorem. I hope you've learned something today. And remember, the more you practice geometry, the more you keep your mind in shape.